Okay, the trig equations. Let's solve next set of trigonometric equations. Practice some more because it's important topic. It's used in integrals, in differential equations, in derivatives. You just name it. In higher level math and trigonometry. So, okay, first equation, cosine square half of x plus cosine 3x equals sine square half of x minus cosine x. Let's start. So, what do we have? We have half of x, 3x, and we have x. So, what I'm going to do, I'm going to bring together cosine square half of x and cosine sine square half of x. Okay, and that is going to give me formula, and that's going to be this formula. Cosine to alpha equal cosine square minus sine square. So from here, let me move everything on one side and leave on the right side 0. Cosine square x squared plus. So practically sum of square gives us 1 in trigonometry, and difference of square gives us double angle. Okay. Plus cosine 3x minus sine square x over 2 plus cosine x equals 0. So these two, like I mentioned, will create cosine x based on formula with this green mark on the right side. Cosine x and then plus cosine 3x plus cosine x is equal 0. So instead of combining cosine x and cosine x, I'm going to do the following, because having two coefficients is not going to do much. Maximum I can take 2 outside and do the same thing. Anyway, so I'm going to apply cosine alpha plus cosine beta. Okay? And it's going to give me 2 cosine x plus 3x over 2 cosine x minus 3x over 2 and plus cosine x equal 0. So from here we are going to have 2 cosine 4x divided by 2 cosine 2x. Next it's going to be cosine negative x and plus cosine x. I have to say cosine is just, I guess, remind you, because in my previous video I have made the previous videos in Precalculus I have explained it, that cosine x is an even function. Cosine x is an even function. What does that mean? That means that cosine negative x is equal cosine positive x. Therefore, we are going to get 2 cosine 2x cosine x plus cosine x equals 0. All right. Common factor, obviously, cosine x, and I'm getting 2 cosine 2x plus 1 equal 0. So from here, cosine x is equal 0, it's multiplication, and x is equal pi over 2 plus pi n, and cosine 2 cosine 2x equal negative 1, right? Cosine 2x is equal negative 1/2. Maybe it would be better this one. I'll write down full format. Plus 1 equals 0, and here cosine 2x is equal negative 1/2. And from here 2x is equal, if you look at the unit circle, it's negative 1/2 is a plus and minus 2/3 of pi. I believe I should have here, no, plus and minus 2/3 of pi plus 2 pi k, and x from here is equal plus minus pi over 6 plus pi k. Okay, so the answer from here pi over 2 plus pi n and plus minus pi over 6 plus pi k. Okay, moving to second one. 4 cosine square x minus sine 2x equal 1. All right, so let me put everything on one side, and since I have here square, I have here 2x, I'm going to bring sine square, cosine square. That's gonna help me. So this one I'm going to break down as a sine squared and cosine square x. So we have 4 cosine square x minus 2 sine x cosine x minus cosine square x minus sine square x, because I am moving over on this side, right, equals 0. Now, as I have mentioned in my previous video, when you have multiplication between sine and cosine, and then separate term is a sine and separate term is a cosine, then usually you are asking for help, going for help, either using either tangent or cotangent. Okay, so since what do I have? I can divide either by cosine square x, because I have equal and cosine and sines, and all of them are squared, and here I have multiplication. So since previously I have used tangent, let's do this one with cotangent. Let's do some work with cotangent, yeah? So we are dividing everything then by sine squared, because just quick reminder, cotangent x is cosine x by sine x, right? So if we divide, since we have square, I'm going to divide by sine square, and hence we will get cotangent square. So dividing by sine squared, so I'll put here twice instead of sine squared, because I'm going to cancel. Cosine square by sine square x, sine square x by sine square x. And this is the picture we get for cotangent square x, right? This is gone with this, let's say, and minus 2 cotangent x, and what else we get? Yeah, minus cotangent square x and minus 1 equals 0. So from here, combining like terms, we are getting 3 cotangent square x minus 2 cotangent x minus 1 equals 0. All right, so we are hitting again quadratic equation. So we're already familiar what we're gonna do. So I'm plugging cotangent x is equal y and writing down 3y squared minus 2y minus 1 equal 0. So I'm not, okay, real quick now, I can write down y1 and 2. I'm not going to write down the whole formula for this quadratic equation. You already have it, you know it. I used in my previous video, so we're using a dominant. So 2 plus minus 4 plus 12 divided by 6 is equal to plus minus 4 divided by 6, and we have y1 is equal 1, y2 is equal 1/3. Okay, so back to our trig problem. Cotangent x is equal 1, cotangent x is equal negative 1/3. I forgot, because at the 2 minus 4, right? Negative 1/3. Okay, so from here, cotangent x, when cotangent will be 1. So tangent is sine by cosine, cotangent is cosine by sine, right? So we get 1 when and sine and cosine have same value. If you open your unit circle, you will see only 45 degrees, which is pi over 4, have the same value. Therefore, always cotangent 45, tangent 45 also going to be pi over 4. So pi over 4 plus pi n. Now, if you wonder why pi n, when we use sine cosine, we put 2 pi n, because tangent and cotangent have period is 1 pi. Okay, tangent x. If you go to my previously videos in Precalculus, when I'm talking about functions, sine, cosine, tangent, cotangent, period is 1 pi. And sine x, cosine x, period is 2 pi. Okay, all right. So x is equal pi over 4 plus pi n. And since here we have cotangent negative 1/3, we don't have a value of negative 1/3. So you can go around this unit circle, see in what case if you take value cosine divided by sine, you get 1/3. Or the easiest way, you can just write down x is equal arctangent, cotangent negative 1/3 plus pi k. And that's it. Since let me see, yeah, and the arctangent negative 1/3, it doesn't satisfy rule of cotangent. So the answer is going to be pi over 4 plus pi n. Okay, and moving to the last question. Sine square x plus 14 sine x cosine x equal 15 cosine square x. All right, so obviously I'm going to bring 15 cosine square x to the left side. So sine square x plus 14 sine x cosine x minus 15 cosine square x equals 0. Okay, so what we are going to get, again, see, we have sine, cosine, and then sine x, cosine square x. So in cases like this, the best way to divide. Okay, so you either can divide by sine or cosine, doesn't matter. In one case you can work with tangent, in another case you work with cotangent. So I'm dividing by cosine square this time. In the previous one I worked with cotangent, now with tangent. Divided by cosine square, well, this time I'll just put cosine square x, and divided by cosine square x. This is gone. This square is gone. Let me use this color. Square is gone with cosine. And we have sine x over cosine x. And that's pretty much it. We are getting tangent square x plus 14 tangent x minus 15 equals 0. Well, again, real quick, I'm not going to solve it here. You know how to solve. I'll just write down y squared plus 14y minus 5 equals 0. Actually, yeah, this is very easy, so we don't even need the discriminant. All I will do, just FOIL it. So it's going to be what? It's going to be 15 and negative 1, right? Y plus 15, y minus 1 is equal 0. So y is equal negative 15 and y is equal 1. Going back to our trig function, and we are going to get tangent x is equal negative 15, x is equal negative arctangent 15, because see, we have tangent negative 15, because tangent is odd function. Tangent negative x is equal negative tangent x. The same way cotangent also. Therefore, we had tangent negative 15, so we just negative moved out. We got arctangent positive 15 plus pi n, right? And here I get tangent x is equal 1. When tangent equal 1? When x is 45 degrees, right? 5 over 4 plus pi n. And again, pi n, because our period is 1 pi for tangent and cotangent. And to remind you why I used here arctangent, here I use just half a pi, because we don't know how much tangent x, which angle of tangent equal negative 15, and even unicircle will not give you answer. There are either some, maybe on internet you can find, there is a special table for all angles that are not on unit circle, but between these angles on unit circle, or you can use function arc. Okay, so therefore here I used arctangent, and in the case of 1 I know already it's 45 degrees. Okie dokie, thank you for watching. Based on your likes, I will figure out if I should continue more of trig functions or move to some different type of solution. Just let me know, comment or like, so just give me a sign. Okay? Okie dokie. See you again.